Hello students, welcome to the second part of the problem discussion class. In the last class I discussed some 8 problems. Some of the problems were from examination question papers, and also I discussed some problems related to other concepts. Today I will continue the discussion of the problems related to refraction of spherical surfaces. The ninth problem: a beam of light converges at a point P. Now a lens is placed in the path of the convergent beam 12 cm from P. At what point does the beam converge if the lens is a convex lens of focal length 20 cm and the second one concave lens of focal length 16 cm? This is basically a problem related to lenses. In fact, already I discussed problems related to lens maker's formula, but once you consider lens formula, you have the idea 1 over f is equal to, that is reciprocal of the focal length, will be equal to 1 over b minus 1 over b. The negative sign is only because of Cartesian sign convention. Okay, this is the basis for this one, and in fact, basically here we will be coming across the fractions. Especially while working out the problems, it is better to simplify the formula before going for the substitution. Therefore, I will write the formula for f, okay, which will be useful. That is, once I consider 1 over f, LCM is Vu, and here it is U minus V. Therefore, f will be equal to UV by U minus V. This is the simplified formula for focus. Because if you use this one, directly you can just multiply and subtract and find out the ratio to get the focus. If we use this one, you have to take LCM and then you have to simplify it. Okay, therefore, always it is better to remember this, and this holds good for lenses. Okay, you have to be very careful. This is one. And sometimes what happens is, if V and U values are there and if FF has been asked, this is what we have to use. Sometimes what happens is, they will give the focal length, they will give the object distance, and they will ask you to find out the image distance. In that case, you can simplify this equation. Now, if I write this one for 1 over V, then it will be equal to 1 over F plus 1 over U. Okay, therefore, 1 over V becomes equal to UF. This is U plus F. Therefore, V becomes equal to UF by U plus F. Okay, this is the formula for image distance. Therefore, if you are given with object distance and focal length, directly use this formula for finding out the image distance. Similarly, from this one, if I consider 1 over U, it will be equal to 1 over V minus 1 over U. Therefore, 1 over U, if you compare, VF is the LCM and this is F minus V. Therefore, U becomes equal to FV by F minus V. Okay. These 3 formulae you have to remember. Okay, sorry, it's not visible. This U becomes equal to FV by F minus V. These are the 3 formulae that you have to remember. Okay. Yes. After considering these 3 formulae related to this, now let us consider the formula related to magnification. Magnification, if you consider, the general formula is Hi by H. But in case of lenses, it will be equal to V by U. Okay, therefore, once you consider this V, here itself you have the formula for V in terms of U and F. If you substitute V, that is UF by U plus VF, then U cancels out. Therefore, the formula becomes M is equal to F by U plus F. Okay, this also it is better to remember. And one important thing that you have to remember is, in case of mirrors, we come across minus V by U. But here plus V by U will be there. Okay, therefore M is equal to F divided by U plus F. Okay, this is the formula. Similarly, if you substitute for U, which is FV by F minus V, then formula for magnification V, and this is FV by F minus V. Therefore, F minus V by F will be get, or it simply becomes 1 minus V by F. Okay, this is the formula for magnification in terms of image distance and focal length. Okay, therefore, this formula you should be knowing. If you know the formula, then it will be easy for you to work out the problems related to lenses. Okay, and I'll just mention one more formula related to combination of lenses, and that is, once you place the lenses in contact, 1 over f will be equal to 1 over f1 plus 1 over f2. If you write this formula in terms of power, power will be equal to the power of the first lens plus power of the second lens. Okay, these are all the formulae that you come across during the study of lenses. Okay, now let us come to the actual problem. Already I read once, I will read again. A beam of light converges at a point P. Now a lens is placed in the path of the convergent P, 12 centimeter from P. At what point does the beam converge if the lens is a convex lens, a focal length 20, and a concave lens of focal length 16 centimeter? There is a converging beam. And basically, the absence of lens, it converges to a point, say P. But now, what actually they have done is, they have introduced in the first place a convex lens in the path of the convergent P. Okay, the convex lens has been introduced. Already you know, convex lens is the converging lens. Already the rays are converged. Therefore, this one bends the rays further, and therefore the rays will converge to a point. Okay, let us consider it as P dash, or let us consider it as I. This is the position or the point where actually these rays go and converge in the absence of the lens. But the lens is basically making the rays to converge at this point because it is a convergent lens. Okay, this is what you have to consider. But they have given this distance, and the distance at which basically lens has been introduced with respect to P is 12 centimeter. 12 centimeter is the one. Okay, but final point of convergence is at I, and we have been asked to find out this. In fact, you can consider this as object. In fact, it is working like virtual object. It is virtual object, and the object distance is 12 centimeter, but its real image is being formed at the point I. Therefore, this is B, and we have to find this one. Focal length has been given, and the focal length is 20 centimeter. It is plus 20 because it is convex lens. Okay, this is the first part of the problem. In the second part, basically they have used divergence, and again the same converging beam is being made to incident on this. In the absence of this would have been the point where the rays have converged, and this distance has been given as 12 centimeter. But as this is a diverging lens, it won't converge, it won't increase the convergence, but it decreases the convergence. Therefore, the rays, instead of converging at the point P, they converge at some point here. And this itself is I. Okay, that means the point of convergence moves away from the lens. Okay, this we have to consider now as V, and this also we have to find. Second. Now we have to work out this one. The formula already you know 1 over f is equal to 1 over v minus 1 over u. And already I have written the formula for v, which will be equal to 1 over v. If I consider, it will be equal to 1 over f plus 1 over u. Therefore, it will be equal to uf by u plus f. And if you just observe the diagram here, this is the point where they converge in the absence of the lens, and already I mentioned it is object distance. And with respect to incident light, we are measuring the distance from the optic center, and the distance is measured in the direction of the incident light. Therefore, u is positive, and it is we are getting this one here, and that part we have to find. Therefore, v if we consider, it will be equal to this is 12, it is 20 divided by 12 plus 20. Therefore, it is 240 by 32. Okay, this is the value, and in fact, if you simplify, it comes out to be 7.5 centimeter. That means it is made to converge. That convergent beam will be made to converge at a point, right? Which is just at a distance 7.5 centimeter from the lens. Okay, here you have to be very careful. You have to take u as positive only, as the position of the virtual object which we are considering here is here, and we have to measure the distance along the direction of the incident light itself. Therefore, positive 1, and we also we are getting positive, which clearly shows the image is here. Now let us come to this one, and the focal length here has been given, and it is as a concave lens. Therefore, focal length is minus 16 centimeter. This is the value they have given. Therefore, again, same formula, b is equal to uf by u plus f. In this case, u is, well, there is no change. Sign is also positive. This is plus 12. Again, the same reason. And 12 into minus 60 divided by u, is 12 minus 60. Therefore, it is minus of 12 into 16 divided by minus 4. Therefore, minus sign cancels out. Therefore, it is 48 centimeters. That is what I told. The rays will be made to converge at a farther point. Okay. The point of convergence moves away from the lens. Here the point of convergence moves towards the lens. Here it moves away from the lens. This problem is there in the textbook. Okay, therefore, definitely it will be asked. Okay, this is the problem related to this. Yes, this is ninth problem. I hope you have no doubt regarding this. In fact, diagram is not essential, but diagram always helps us to understand the physics behind the problem. Yes. Again, one more problem is there related to lens maker's formula only. Again, it is a problem from the previous examination paper, that is June 2018 question. The radius of curvature of two surfaces of a convex lens are 0.2 meter and 0.22 meter. Find the focal length of the lens if the refractive index of the material of the one is 5. Focal length in A, we have to find. Also find the change in focal length. Afterwards, what actually they are doing is they are immersing the same lens and they are placing the same lens in water. Refractive index of water has been given as 1.33. Focal length in water, but we want delta F. Okay, we have not been asked to calculate FW, but change in focal length we have been asked to find. But focal length in water, PFW. Gradient of curvature will be same. That is 0.2 plus, and this one will be minus 0.22. Already in the last class itself, I have given the idea why it is negative. Because of this surface, the center of curvature will be here, radius of curvature is measured in the direction opposite to the direction of the incident light. But for working out this, first of all, you have to consider the first one, the focal length in here. And already you know it is Ng minus 1. I use Ng itself. Refractive index of the material of the lens into 1 over R1 minus 1 over R2. Therefore, it is 1.5 minus 1, 1 by 0.2 plus 1 by 0.2. This is for the first part of the problem. And therefore it becomes 0.5 into this is 0.22 plus 0.2. LCM is 0.2 into 0.2. Therefore focal length here is 0.2 into 0.22 divided by 0.5 into 0.42. Okay, just simplification. The simplified answer is 0.2095 meter. The focal length, the lens is 0.2095 meter. This is focal length in air. But we have been asked to find out the focal length in the change in focal length. Okay, that's why once you consider focal length in water, it will be equal to Ng by F minus 1 into 1 over R1 minus 1 over R2. First, let us write the formula. Let us call this equation number 1 and this equation number 2. 1 divided by 2 is then avoid the substitution. Otherwise, directly substitute the values and simplify. That also you can do. Okay, directly substitute because already you know this part. Okay, again you can substitute directly 1 by FW. This is 1.5 by 1.33 minus 1. 1 by 0.4 plus 1 by 4. I hope we can simplify this. And the simplified answer for FW is 0.845. Just observe what is happening to the focal length. In the air, its focal length is 0.2095. But in water, the focal length of the same lens has become 0.8245 meter. One important thing you have to remember, especially if NG is considered as 3/2, that is 1.5, and NW is given as 4/3, it is just exact 1.33. In fact, focal length in water is nearly 4 times the focal length in the air. Okay, for these values, this will be the one. Therefore, especially for competitive examinations, it is better to remember this idea. Okay, once you immerse in water, and if they are given the values of this Ng 1.5, this one is 1.33, the focal length in water will be 4 times focal length in the air. That's why, especially for competitive examination, you can remember the formula for delta F also, which is focal length in water minus focal length in air. This is 4 times FA minus FA. Therefore, it will be 3 times FA. Therefore, you can easily choose the nearest value, especially if you are given with problem related to water. Okay. But let us here find out the same delta F. If you consider its focal length in water minus focal length in air, which is 0.8248 minus 0.2095, this is 0.6153. This is delta. And you just observe, this is 0.2, 0.6, okay, which is 3 times. Okay, that will be the idea clearly. It will be useful for you. Okay, this is how it's good only for these values. If there is any deviation, say 1.545 like that, variation happens. But exactly if these values are given, then this will be the answer you get. Okay. Take on the screenshot and move on to the next problem. Yes. Next one, it is 11th problem. 11th problem. An object of 3 centimeter is placed, that is, height of the object has been 3 centimeter, is placed 14 centimeter in front of a concave lens. Concave lens of focal length 21 centimeter. Find the position, nature, and size of the image form. Okay. Already you know, once you consider a concave lens, when you consider any object in front of it, it produces only virtual image and it will be diminished one. Okay, this is the basic characteristic related to concave lens. In case of convex lens, if the object is within the principal focus, the image will be virtual and it will be enlarged. If the object is placed exactly at the principal focus, that is focal point, image will be produced at infinity. If it is in between f and 2f, that means at a distance twice the focal length or less than that and greater than f, then the image will be beyond 2f and it will be magnified image. If the object is placed exactly at 2f, you will be getting the image. So size will be same as the size of the object and the distance will be same. When u is in 2f, p will be equal to 2f. And once the object is placed beyond 2f, the image will be formed between f and 2f. Okay, these points you should be knowing. Because if you know this idea, during the simplification, by mistake, if you get wrong answer, you can easily identify. Identify ಮಾಡಕ್ಕೆ ಒಂಚೂರು ಚಾನ್ಸ್ ಇರುತ್ತೆ. That's why